All right, hello, sixth graders. Sorry I can't be there with you today to go through this. So the sub should have given you a worksheet with the notes copied on the one side. As you're watching this video, you should go ahead and fill in the notes as we go. The great thing is you can pause the video if I'm going too fast. You can rewind it if you need to hear something again. And then just make sure that you get this taped or glued into your notebook when you're done so you don't lose it. If you remember earlier this unit, we talked about proportions and what it means to be proportional or non-proportional. And the way that we looked at it earlier was talking about kind of that multiplicative reasoning. Could you multiply the numerator and denominator or the top and the bottom of a ratio by the same number and create another ratio, and then they'd be proportional? And if you couldn't do the same number, then they were non-proportional. So proportions are always just an equation that states that two ratios are equal. Since we had done the multiplicative reasoning earlier, you could still continue to use that, but as we get further along, sometimes our numbers aren't as nice to work with, and so then we actually can start to use an idea of what is called cross products to determine if two ratios form a proportion. And what that means is if we have two ratios, so like A over B equals C over D, the cross products are going to be A times D, and that has to be the same as B times C. So that's what forms those cross products. So here we're going to use that idea to determine whether the pair of ratios forms a proportion. So the first thing we're going to do is we're just going to set up our cross product. So I'm going to do 5 times 24, and that has to be equal to 6 times 20. In this case, 5 times 24 is 120, and 6 times 20 is 120. So yes, these two would be proportional. Let's look at our next one. We're going to look, we have 2 times 15, and that has to be the same as 3 times 8. In this case, 2 times 15 is 30. 3 times 8 is only 24. So this one would not be true, so no, they do not form a proportion. Why don't you go ahead and pause the video and try the next two on your own, and you can go ahead and use a calculator if you need it. Hopefully you tried these two problems. So now if we look at this, we're going to have 0.5 or 5/10 times 40, and that has to be the same as 18 times 1.5 or 1.5. Well, half of 40 is 20, and 18 times 1.5 is 27. So these would not be proportional. And then on the next one, we have 16.2 times 38, and that needs to be the same as 68.4 times 9. 16.2 times 38 should end up being 615.6. That was, and 68.4 times 9 is also 615.6. So yes, these are proportional. Now some of these, like I said, you could have reasoned out with multiplicative reasoning. Like number 1, we know that 5 times 4 is 20 and 6 times 4 is 24. And even the second one, that 2 times 4 is 8, but it would be 3 times 5, which would be 15. but it's just nice to have this cross product option as you're looking at ones like number 4 and number 5 that aren't set up as nicely to just know what the multiple is. We often use proportions in real life as well to figure out missing quantities. So here, a 100-ounce jug of liquid laundry detergent can wash 64 loads of laundry. And we just want to know how many loads could a 150-ounce jug of detergent wash, assuming that it would be the same size that would go in per load. So the first thing we want to do is we want to set up our ratio of what we know. So in this case, we know a 100-ounce jug can wash 64 loads. This is going to be a part-to-part ratio because we're comparing two different units. So really the order that you write it doesn't matter. I can either put it 100 ounces per 64 loads, or I can do 64 loads per 100 ounces. Since it's listed as ounces to loads, I'm going to go ahead and go with that. And I'm just going to make sure that I label it as well, just so I can keep track of what I am writing. So I have 100 ounces of detergent creates 64 loads of laundry. And we want to know if I have 150 ounces, how many loads can I make? Since I had done ounces on the top for my first ratio, I need to make sure that I put ounces on the top for my second ratio, so I'm comparing like to like. And I'm going to put my unknown on the bottom because I'm trying to figure out how many loads. And now I can just use that whole idea of cross product. So I'm going to take 64, multiply it by 150, and that has to be the same as 100 times x. And if I do 64 times 150, I get 9,600. And that has to equal 100 times x. So I'm going to divide both sides by 100 to undo the multiplication. What we end up with is 96 loads is equal to our x. Now let's just look at some of these types of problems that aren't in a word problem situation. So here it's just going to be strict either cross multiplication or multiplicative reasoning. On this first one, for example, you could actually even go what we had done before, and you could say, well, I know that 3 times 4 is 12, so you could use that inverse thinking to think that 16 divided by 4 is going to give us 4. Otherwise, the other option could still just be using cross products, in which case we can look at 12 times x is the same as 16 times 3, and 16 times 3 is 48. And since it's 12 times x, we're going to divide both sides by 12. So x is going to equal 4, which we had found out already. Either way is totally acceptable. You just have to use whatever is going to be probably the most efficient for you per problem. So let's look at another one. So here I'm just going to go ahead and use cross products. So on this problem, I have 7k is equal to 8 times 21. So when I do 8 times 21, I get 168. I'm going to divide both sides by 7. So k is going to equal 24. Once again, I could go back and check that using that multiplicative reasoning. 7 times 3 is 21. 8 times 3 would be 24. Why don't you go ahead and pause the video and try these last two out on your own. All right, hopefully you paused the video and tried both of these out. Now this one, number 9, it doesn't work as nicely for that multiplicative because 5 doesn't multiply into 26 with a whole number. So here we might be better off using our cross products. If we take 26 times 6 and I want it to equal 5W, 26 times 6 gives me 156, which is going to equal 5W. Divide both sides by 5, and I get an answer of 31.2 is equal to W. Right. So on this last one, we could use multiplicative reasoning or we could use cross products. Here I think the using division or multiplication is going to be a little bit more efficient. For example, 63 divided by 7 gives us 9. So I could do 14 divided by 7 and we would get 2. If you do it with cross products, 9 times 14 has to equal 63A. 9 times 14 is 126. That has to equal 63A still. Divide by 63. And we still get that answer that 2 equals A.